Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is trace path, which is an easy level problem. So first of all, I would like to thank you all because for the past few days I've been experimenting with this new thing where I ask the viewers to like the video if they enjoy the content or if they are able to understand the solution. Because if you like this video, YouTube understand that this video is actually good, and it has played out really well, and I've seen amazing support from you guys because for the last few videos I've been receiving more likes, as well as it was able to reach more number of people. I've seen the difference in the number of views. So I would like to thank you all for your support, and I would like to thank you all for watching these videos, and we are very close to hitting 1000 subscribers. So let's just make it as soon as possible. And again, I would like to thank you because of your support, and because of you people watch these videos, we will be able to reach this particular milestone. So let's just hope we reach it as soon as possible. And again, as usual, if you find this video useful and if you were able to understand the solution, then do drop a like on this video and show your thoughts on this particular question or any general thing that you want to share in the comments, because engagement like this on this particular video will really help the YouTube algorithm to understand that this video was actually helpful for you and you find this video useful, and it will recommend this video to more people like you who want to keep solving these kind of new problems. So let us quickly start with the problem discussion now. It says that we have been given a rectangular grid. So actually we will be just given two values, where n will be the number of rows and m will be the number of columns, right? So they say that the train will start from one of the grids. They have not mentioned which grid will it be, and we have been given a series of string, like it will be series of characters, a string which will contain 4 directions, right? So L represents left, R represents right, D represents down, and U represents up, right? So we have to follow that particular string, and we have to tell whether it is possible to start from some cell such that the train always remains inside the grid, right? So this is our question. Now I believe the sample test case are not enough, so we'll just directly discuss the problem in our own way. So they say let's say there's some grid, right? They have not mentioned the starting cell in which we'll be starting, but they have just mentioned the grid. So they say let there be some starting point, right? And then we'll be given a series of instructions that can be left, right, down, up, and right, up, left. Like it can be a string like this. Now we have to identify whether there exists some starting cell for which this string will be a valid string. What do we mean by a valid string? That is, when we follow this direction, we must not fall out of the grid. Right? This is our requirement. So for example, if I start from this particular position, then if I go up 3 times, so one time up will be here, second time will be here, and third time I'll get out of the grid. So this is not a valid position. But if I start from here, I will get 1 time up here, I'll get 2 times up here, I'll get 3 times up here, right? So this way, this will be a valid position to start the traversal, right? So we have to solve this particular question, that we have to identify whether there exists such a starting point or not, for which this particular string is a valid traversal string or not, right? So let me just simplify this question a bit. So instead of looking at the 2D array, let us just try to solve this on a single dimension array, right? So we are just considering the x-axis first, or you can also take the y-axis, it doesn't make a difference. So let us just take the x-axis. Now let's say you have a starting point here, right? So what is the maximum distance to the right that you can go? So let's say we stored this information in a pair. So the maximum distance to the right you can go is 1, 2, 3, 4, 5, right? This is the maximum distance you can go, and the maximum distance you can go on the left is 0, right? So let me just store 0, 5 here, right? For this particular cell, the maximum distance to the left you can go is 1, and the maximum distance to the right will be reduced by 1 now, so it will be 4. For this particular cell, the maximum distance to the left will increase by 1 and the maximum distance to the right will decrease by 1, so it will be 3. For this particular cell, it will be 3, 2, and then for this particular cell, it will be 4, 1, and for the last cell, it will be 5, 0. Right? So you see, for any of the points, no matter which point you take, even if you take the first point, the summation of these values is 5. if you take this particular point, the summation of these values is 5. The summation of these value is 5. Again 5, 5 here also, and at the last operation also 5. So what is this 5 indicating? So 5 is indicating that if you move some spaces to the left and if you move some spaces to the right, respective to your starting position, then the summation of the distance that you have moved to the left and right should not exceed 5. Why only 5? Because 5 is the width of this particular array, one-dimensional array, right? So I'm just trying to explain you, although this would be very intuitive when you solve the problem, right? This particular method will not be very difficult to think of, but I'm still trying to like give you a proper proof of why this works, right? So if you have a starting position x and you calculate your change in position dx, right? So let's say you move one space to the left, so dx will become -1. You move one space to the right, dx will again become 0, -1 plus 1 0. Then you move one space to the right, again this will become +1, right? So you have to take this particular value, you will take the absolute of it because you will be moving one space to the left and this particular absolute value, so the distance will be 2, right? Or you can also do it like 1 minus -1, right? You can subtract this particular value minus this particular value, so it will also be equal to 2, right? So we will be using a variable dx to store the change in position from the original starting position, right? And we know the number of spaces we move to the left and the number of spaces we move to the right, if you like add both of them, it should not exceed the width of the array, right? So this is our core idea. So obviously 1 minus -1 should not be greater than or equals to the number of rows, right? So this is what we will be doing. So let me just quickly summarize what I just said. We observe that if we start from any point, the summation of the number of spaces we move to the left and the number of spaces we move to the right is always going to be equals to the width, and width is always equals to number of rows minus 1, right? So it is always going to be this. So if we are trying to like form our answer, we move some spaces to the left, we move some spaces to the right, we see that the width for this particular value is exceeding n minus 1. That is the case, we understand that our answer will never be possible, right? So we can do the same thing for the y-axis also. We can just deal these two cases independently. They don't affect each other. We can just treat them as independent arrays and we can find the answer for both of them. Even if one of them fails, that is when we can just directly return 0 or the answer will not exist for our case, right? So let me just show you the code quickly. So what I've done is I've created two variables dx and dy and I've calculated 4 variables. So max x is the maximum position to the right that you will move. Minimum x will be the minimum position to the left that you will move. So basically this is for going right and this is for going left. Similarly, I've done it for y. So this is for going up, this is for going down, right? I initialize all of them with 0. So now what I do is I just traverse to the string. If I is equals to L, I decrement dy. So this is, you can just also see it from here that the j-axis will decrement by 1. So this is the same thing, right? If I is equals to R, that is when I move to the right, dy will increment, right? And similarly for all the other cases as well. Now what I do is I just set my maximum x as maximum of dx comma max x and maximum y is maximum of dy comma max y. So similarly I also set the minimum value. Now I need to check whether the maximum minus minimum. So you can also take their absolute value and add both of them. This will denote the width I have traversed in the x-axis. So if it is not greater than equals to n, right, then it is fine. But if it becomes greater than or equals to n, or even if the same thing occurs on the y-axis, so max y minus min y is greater than or equals to m, that is when I have to return 0. That means my answer will not be possible for the current case. Otherwise, I can just directly return 1 once I get out of this for loop, right? So this would be the solution of today's problem of the day. I hope that you guys were able to understand the solution. So let me just quickly summarize it and show you that this works. So we'll have a result in a while. Yeah. So you see that this passes all the test cases, and I hope this video was helpful for you. If it was, then consider dropping a like on this video. It really helps the YouTube algorithm to understand that you enjoyed the content and this video was helpful for you. And don't forget to subscribe to this channel. I see a lot of people who watch these videos have not subscribed yet, and also we are very close to hitting 1000 subscribers. So let us just quickly do it. And till the next video drops, keep sharing this channel with your friends, keep coding, stay safe, bye bye.